Now I'll discuss the D flip-flop. In case of a D flip-flop, there is only one input and Q and Q bar. The output will be the Q and the Q bar is the complement of Q, and then C is the pulse, clock pulses, and that also I consider as a positive trigger. Again I repeat that in case of a positive trigger, that the change of Q only will takes place when the state of the pulse changes from low to high, and remaining time there will be no effect on the output Q. That is the positive edge triggered. Now here also we have considered this is a positive edge trigger. Therefore, you can see that D, whenever D equal to 0, they will come to the truth table when D equal to 0, Q equal to 0, and that effect, that means change of Q will takes place only at the arrival of the pulse. That means positive edge, arrival of the positive edge, that the Q will get the same value as of D. Therefore, D equal to 1, Q. This is the truth table. Now we can come to the state transition diagram here. In the state transition diagram also shown the same thing. It is the when it was a previous state was 0, it will remain as 0. What are the condition when D equal to 0? Because at D equal to 0, Q is also equal to 0. When it will change the state from 0 to 1, when D will be equal to 1. When D equal to 1, it will if the previous state was 0, it will change to state 1, and it will remain as 1. It will remain as 1. What are the condition? It will remain as 1. This is the remain as 1. What are the condition? It is when if it is D equal to 1, if the previous state is 1, it will remain as 1. Now from the state 1, it will come to 0 state 0 when D equal to 0. That from the exactly this being prepared from the truth table itself. Now after the preparation of the state transition diagram, we come to the preparation of the excitation table. Excitation table exactly from the state transition diagram. When previous state was 0, the next state is also 0. What are the value of D it will take? It will take a value of D equal to 0. When it will change from 0 to 1, what is the state? D equal to, you can see D equal to 1. If your previous state was 1 and next state is also 1, then what is the D equal to 1? If it states from 1 to 0, then D should be equal to 0. Therefore, it is exactly representing the actually in the state transition diagram only, excitation table. Now from the excitation table, if we plot the K-map for Q n plus 1, that is the next state, in terms of Q and D, then we can see that when Q n equal to 0, D equal to 0, that means this is the block, and Q n plus 1 equal to also 0. When Q equal to 0, D equal to 1, that means this is the block, and you can see the output is 1 here. Output is 1. Now when previous state is 1 and D equal to 0, that means this is previous state is 1, D equal to 0, that is we are here next state is 0. When the previous state was 0 and D is equal to 1, that means this is we have put it here, and therefore we got the K-map, and we simplify the K-map. After simplification, we make a group, and you can see very clearly that this is nothing but D. Therefore, this is the characteristic equation. This is the characteristic equation for D flip-flop.